Hello, everyone, and thanks for joining another session of Romania Power BI and Modern Excel User Group. This is our 9th meetup, and we have the pleasure to have Alberto Ferrari as our special guest. We'll go through some starting slides, and then we will give the stage to Alberto to introduce us to direct query for Power BI datasets over analysis services. What a long name. So just a few introductory slides. We'll have a short introduction with the next meetups. Then Alberto will deliver the feature presentation. We'll have a short Q&A in the end, and after the Q&A, we'll run our usual raffle, which is sponsored by Enterprise DNA, our primary official sponsor. Only a few points, organizing points. I made sure that the microphones are muted during the session, so there's no need to mute the microphone anymore. If you have questions, please type them in the chat area with a Q in front of them so we can spot them and address them to Alberto. And if you have problems with the internet connection, just drop off and join again. The recording will go on, and you won't miss anything. So just to make sure that I will record. I added a bullet here that meeting is recorded. So whoever wants to stay, it's more than welcome. If you don't want to get on YouTube afterwards, so not a problem. Our next meetups are in November. We will have as a guest Andrei Lapagne from SQLBI. The final details are not established yet, but it will involve something with very cool SQLBI visuals. And then the last session of the year will be with Mr. MVP Excel, Mr. Bob Umlas, with a session with Excel tips and tricks that everybody, regardless of the level working and where are you working, if you have Excel and you open it every day, you need to see this session. As I said, we have a great partnership with Enterprise DNA, who is our primary official sponsor. Enterprise DNA is offering each month 3 full annual Enterprise DNA membership and 3 annual Analyst Hub memberships to Romania Power BI User Group with a total value of over $1,500. And the only condition for them is to participate in the raffle, because we have a raffle at the end of each monthly meetup. Just fill up this form, state your option whether you want in or out of the raffle, and we'll run the raffle for 3 membership at the end of the meetup. I will put the link for the form in the chat periodically during the Alberto's session. So let's go back to our session. We are very, very fortunate today to have Alberto Ferrari as our guest. Whoever is working with Power BI heard about Alberto. At least I don't think there is anyone in the Power BI world that doesn't know Alberto. Him and Marco Russo are the founders and partners in SQLBI. Alberto is a very prolific book author, DAX master, DAX teacher, data modeling teacher, you name it. Everything that is related to DAX is Alberto's main focus, right, Alberto? We were just talking at the beginning of the session. we've actually met in 2016, 5 years ago in October in London. I was a student at the time. It was too much for me at the time. It's still a little much for me. This is why I'm taking the second version of Mastering DAX course. I'm just redoing it, so I'm halfway through. But I'm sure that every time anyone is passing through the same course, the understanding is different, and this is the reason why I see so many known names that are coming and learning and keep learning and keep seeing new things. I've learned a lot from SQLBI.com, and I encourage everyone to check the website. There are a lot of great articles, great courses, and the definitive guide to DAX is actually the DAX Bible, as we are saying. So thank you for everything you're doing for the community, Alberto, and thanks again for accepting our invitation. The stage is yours.
Thank you. So I first need to share the screen. I guess this one.
Yeah.
Sounds good. You see me?
Yes, I see you, and I see an empty Power BI.
Well, an empty Power BI desktop, yes.
Yes.
Because I'm going to deliver the session. We have no slides at all. We just run demos, play a bit, and discover details about composite models. Now, before starting to talk about composite models, I need to first answer to you. The official name is Direct Query for Power BI Dataset and Analysis Services, blah, blah, blah. This is the official name of the feature that we are going to talk about. It's a long name. It's not evocative at all. I hate it, and therefore we just call them composite models. It's much, much easier. That means whenever you hear me talking about composite models, I'm actually talking about Direct Query for Power BI Dataset and Analysis Services tabular solution. And another detail that is worth saying from the beginning, because I saw one question in the chat, this stuff is not yet generally available. It is there. It has been in preview for about a year now. So it's a very long preview, but it's not yet final. There are still some behaviors that are going to change, specifically regarding calculation groups. Calculation groups and composite models, they really do not work really well together. It's extremely hard to understand exactly the rules, and they are still under definition. So if you plan to use composite models, you can, of course, even though it's not generally available, but you need to pay attention that the behavior might change over time. But nothing about the topics that we are going to talk tonight, because right now, this is just an introduction. So we're going to discover what they are, how they work, and what you need to pay attention to when using them. Now, to start talking about composite models, we start talking about live connections. I have an empty model here, which is not an empty model. I made a mistake. I really want an empty model with no connections anywhere. Need to wait for Power BI to start, and there's some special rule that the time when you are presenting seems to move slower. Power BI takes a lot more than usual to start. Now, this is
usually like this.
Yeah, it's always the same. Maybe just 2 seconds, but you are there hoping that it starts. Anyway, this is a really empty Power BI model, and we can start connecting to data. So I just go to Power BI dataset, and from here I'm connecting with Power BI. I search for Contoso, and I have my Contoso 10K, which is a version of Contoso with 10,000 rows. As soon as I click on Create, right now I'm connecting Power BI Desktop with the Power BI service in the cloud, and Power BI Desktop is not it's not storing anything. It just runs queries against the data model. You see that I have sales, I have customer, I have tables. I can see the diagram of my model. For whatever reason, it's okay. So I have all my tables, but these tables have not been loaded inside Power BI. I'm just connected live. And if I run a query, like I take the continent and then I grab a measure like sales amount, just give me a couple of seconds because I want to increase the font and move that to a matrix. Okay, let's drop sales amount. And then let's increase the font. I honestly hate that it uses 10 dots, 10 points for the font, because at my age, 10 points are definitely not enough. So the reason I created this dashboard, this simple visual, is because I wanted to highlight the fact that right now, no data is being stored in the model. I don't have a data view here because there's no data in the Power BI desktop file. And if I save it now, it will be a really tiny Power BI desktop file because the data is still stored in the cloud. Everything stays there, and you can just run queries. Right now, Power BI desktop is acting only as a client tool. It's not storing anything. It's just running queries on top of the Power BI service that is running in the cloud. There is this really tiny button at the bottom, make changes to this model. Composite models work in this way. Right now, the model is a live connected model, so it does not contain any data. If you have some data that you want to create, or you want to create calculated columns, you want to create tables, you want to maybe load data from an Excel file and store it as part of the model, you can't, because the model is not here. And you can see it here. I can create a new measure if I want, but I cannot create new columns. If I want a new column in customer, I simply cannot do that because the option is disabled. In order to obtain the capability of creating new entities, so not only measures, but columns, calculated tables, and relationship in the model, I need to change this model to a composite model. And to do that, it's enough to click on this button. You just click on it, you obtain a warning that explains a lot of things, and then it has a yellow button. Now, I don't know what you do when you see a warning window with a yellow button, but I always click on that yellow button without even thinking about what the message says. But sometimes it's important, like in this case. This PBIX has a live connection to a remote model, we know that. And if you want to make changes, then you need to transform that into a composite model. Keep in mind, this change is permanent. Once done, you cannot roll back. You can just avoid saving the file, but once the model becomes a composite model, you can no longer transform it into a regular live connected model. And what is going to happen when I click on this add a local model? What is happening is that there are a lot of details that are happening right now. First of all, the engine no longer queries the remote model, but it grabs all the information about the tables, the measures, the columns, all the information that is available in the remote model is copied or linked in the local model. And second, all the measures are rewritten, and most important, a new local model is added to the model. If I right-click now on sales, you see that new column that was not available before is available now, in that I can now create new columns, new tables, and modify the model. Now, this it's not that I can modify whatever I want. I can make some modifications. I cannot make some other modifications. And I need to pay a lot of attention to what happens and how the link between the remote model and the local model happens. Because before there was just a link and all the metadata information was stored inside the remote model. By remote model, I mean the model that is published on the service, the Power BI service. Right now, there are actually two copies of the metadata. One is in the local model and one is in the remote model. Moreover, I have two storages. I have the local Vertipack model, which has been created because I transformed the model into a composite model. And I also have the remote model. And a lot of things might happen at this point. because, for example, you may change the definition of a measure in the remote model, and we need to understand what is going to happen to the local model. Or you might change the definition of a measure in the local model, so you override the original measure. And all these details are kind of important to understand. First of all, let's go back to the model. You see that we still have all the information about the models, and we have also something that we didn't have the option of doing before. That is, we can change the properties. We can change properties of columns, properties of tables. We can change a lot of the details. For example, let's say that I want to create a simple column in, let's do that in sales. I want to be able to slice sales by large and small sales. I can just create a new column in the sales table and write a simple piece of code. This is a demo, very quick, but already effective. I can write like a sales category. And it's just check if sales quantity is less than 2, then this is a large sales, otherwise it is small. This is a calculated column that I'm creating on top of the sales table, which is still in the cloud. Remember, no data has been moved. The sales table is still in the cloud, but I'm creating a calculated column, and this calculated column is created only in the composite model. I know I'm pedantic in saying this again and again, but I'm not changing the remote model. The remote model still is the very same as it was before, but now I have a new calculated column, sales category, that works exactly like any other column. I can add it to the columns of my report, and I'm slicing by large and small, and I see the total sliced by continent. There is an important question that we need to start answering very quickly. That is, where is this column? So if the column is not saved in the cloud, and if it is not saved in the local model because there is no copy of sales in the local model, where is actually stored this calculated column? Remember, the original name of the feature is Direct Query for Analysis Services. The behavior of calculated columns created in the local model is the same as Direct Query with SQL Server. If you use Direct Query for SQL Server and you create a calculated column, that calculated column is not stored because Direct Query models do not have a storage. The code of the calculated column is saved as part of the save operation, and then that calculated column will be computed every time you query it. And here the very same is happening. Whenever you query the sales category column, there is no calculation, the column is not pre-computed, and it is sent as part of the query. It's a bit early to do that, but it's worth looking at the code quite quickly. So let's see the query that has been executed to run this matrix. You can do that by going to the performance analyzer. We start recording, then we refresh everything, so we have the code of the matrix, and just copy and launch DAX Studio. Okay, let me connect there. I know you cannot see it yet. DAX query. Okay. This is the query. I made a mistake. Well, DAX and direct query. Okay. This is the query that has been executed to produce that report. You see that it is slicing by continent, by category, and it's computing the sales amount. This is the code that this matrix sent to the analysis services, the local analysis services engine, to retrieve the value. Now, the problem is that the local analysis services engine does not know how to compute the sales amount, because the value of the sales amount can be computed only by the remote server. And the local engine does not even know what the continent values are or what are the sales categories. It doesn't know all the details about the data because, remember, the data is still in the cloud. The thing is, this is the code generated on the local model. As a consequence of this code, the local analysis services engine sends queries to the remote analysis services engine to gather the pieces of information that are needed in order to produce the result. Indeed, after the queries which are executed by the local engine, we have a set of queries which are not executed by the local engine, but they are executed by the remote engine. And you see that we have them here. We have this defined column, sales category, that contains the code that I wrote, and then a set of statements that execute the query. This query, this code, is executed not by the local engine, but by the remote engine, and it contains the definition of sales quantity greater of my sales category. So this is already a very important difference between a model created using Vertipack only and a model using composite models. It is true that you can create calculated columns, but at the same time, you need to pay attention to the fact that calculated columns are not recomputed and then only queried at query time. They are actually computed at query time. And it's also useful to introduce another important concept about a composite model, again, right from the beginning. The code, so the code executed by the remote server contains everything that is needed. So the entire execution has been pushed to the remote server. This is known as a wholesale calculation. So the entire calculation has been pushed to the remote server. It's important to know about the existence of wholesale calculations because a lot of limitations exist in the creation of composite models. And the most strict one is that many calculations need to be wholesale. So the calculation needs to happen in the remote model. It cannot be a mixture of calculation that happen on the local and on the remote model. But we're going to see that with a bit longer demo. Let me close DAX for now, and let's go back to our model. Let's say that we want to do something a bit more complex, like we want to analyze customers. For the customers, we have the age. So I can get rid of the continent, slice it by age. And now I see people of 19 years, 20 years, 21 years, and so on. And I'm slicing also by large and small, which is totally useless, so we can get rid of it. Now, when are composite models useful? Composite models are useful whenever you want to slightly change the behavior of your model. You're not satisfied with the entities, the columns, and the data that the developer created in the remote model, and you want to extend it with more information. For example, I might be interested in slicing age, not by individual ages, as I'm doing here, but slicing ages in buckets. I want young people, mature people, adults, mature people, and old people. So I want different categories. And I can do that with a calculated column. Now we know we can do that. So we can create a calculated column on customer. And let's call it age group. Just do a switch over true, and then we start adding the condition. We say if a customer age is less or equal, let's say 10, then it's a child. It's less than 20, then it's a teenager. If it's less than 54, then it's an adult. I just use 54 because this is my age, and by no means I want to be called an old man. Otherwise, let's call it old. So I now created 4 buckets, child, teenager, adult, and old, and I created a calculated column. We already know this is going to be wholesale, so this code is going to be pushed to the remote server in order to compute the values. And now I can use the column. I get rid of the age. I slice it by age group, and it works. I have adults or teenagers. I have no children anywhere. That works fine, and it poses no problem. It works just fine. But it has a limitation. The limitation, for example, is that if I want to change this table, I need to do that by changing the code of the calculated column, coming here and changing the data. It would be slightly better if I just create a table, a configuration table that contains the different ages of people, and then I start. I use the configuration table in order to do the slicing. I could do that in Excel, of course, or I can use a calculated table to do that. Let's say that I want to do that in Excel. So we just need, we can go for enter data. We just create a new table. Let's call it ages, where we create a new table, data table that contains max age as an integer, then age group as a string. And we just create a table that says that 10 is a teenager. No, 10 was a child, that was 20. Then 54 is an adult. Otherwise, it's old. Let's use 999 and then it's old. Now, again, this is important. This table does not come from data that is in the remote model. So this is not an expression that requires being computed in the remote model. Therefore, being a calculated table that is loaded only in this specific model, this is going to be stored in the Vertipack engine. Again, I know this looks pedantic, but it's important to distinguish between calculations that can be executed by the remote model and calculations that cannot be executed by the remote model. Specifically, this table does not belong to the remote model. The remote model has no way of accessing this table. Therefore, any calculation that involves the ages table requires accessing the local model, and the remote model cannot obtain access to this table. Now, I have created my table. I have it here, max age and age group, and I might want to create a calculated column in the customer that uses this table in order to compute its value. So we can do that, or at least we can try to do that. But as you are going to see, this is going to be a failure. I can go to my age group. And I can, if I want to obtain the age of the current customer, what I could do is search for the minimum age, which is the minimum that is greater than the current age. So I take in a variable the customer age, just the customer age. Then I create all, let's call it greater ages, where I filter the table that I called ages. And you see the first problem. IntelliSense doesn't let me use the ages table, but I can try to do that anyway. You can say where ages age is greater or equal than customer age. And finally, I created the age group, which is just the min x over the greatest ages of ages age group. Return age group. Now, this code, if I were able to access the ages table, would work just fine. But focus on this. This code uses one column that is from the customer table in the remote model, and it is using a table that is stored in the local model. Being a calculated column, the calculated column needs to be wholesale. You cannot create a calculated column if the code of the calculated column cannot be pushed to the server, to the remote server. And again, that is important. The remote server will never be able to execute this code because this code is accessing a local table. And because it is accessing a local table, there are no ways this code will ever be computed. If I try to hit enter, I obtain an error. Column age in table ages does not exist. Actually, that was max age. Okay, and I have now the real error that says the column customer age group cannot be pushed to the remote data source and cannot be used in this scenario. This is important because this is the first relevant limitations of composite models. Calculated columns need to be wholesale. They need to be pushed to the remote model in order to be computed. Therefore, this technique that I was trying to use will simply not work. I cannot use an expression that mixes local and remote tables. So we need to find a different path. A different path is that of changing this code. What I can do is create my ages table as a table that can have a relationship with the current customer table. So instead of containing only 4 values, then I need to search into in order to obtain my result. I can create a different table, a table that contains all the possible ages for each age, the age group, and I will build a relationship between the two tables because it is true that a calculated column needs to be wholesale, but I have the option of creating relationships between local tables and remote tables. And by using this feature, I will be able to solve the problem of grouping without having to create a calculated column that requires using both tables. So we do something different. We create a table ages that contains all no-blank row of customer age. And now I should have my age table, you see, that contains all the possible values for the age. Then we add a column to that. We use add columns. And we add a new column, which is the age group, when we repeat the code we wrote earlier. It would have been nice to save it, but I didn't. Depending on the customer age, switch over true. If customer age is less or equal 10, then it's a child. Age is less than 20, then it's a teenager. I know that you are hating this help, but I don't know how to get rid of it. I'm hating it too. If customer age is less than, as usual, 54, then it's an adult. Otherwise, it is old. So what I created using this code is a completely different table. Now, this table contains the age and the age group. So there is a value for each individual age and the description of the group to which this specific age belongs as part of the table. And if I look at the model, now I have my ages table here. And this is where to introduce another topic. You see that the color of the customer table and the color of the ages table, they are different. Customer is highlighted in blue, ages is just white. What is the difference? Ages is a local table. It's a table that exists in the local model. Customer, on the other hand, is a table in the remote model. Even though ages and customer, they do belong to different data island. By a data island, we mean a storage. It can be the remote storage, it can be the local storage, it can be a direct query storage, but it's a server and the database containing some data. Even though they belong to different islands, I have the option of creating a relationship between age and age this way. And I'm creating a relationship between customer age, where is age here, customer age, and age is age. The relationship is a regular many-to-one relationship, a single cross filter, active relationship. If I click on OK, again, it is worth noticing some small details. First is a many-to-one relationship, a regular relationship. But you see that there is still small gap here in the relationship, which is not present in this relationship. This doesn't have this small separated circle that appears here and not there. What is the meaning of that? This is a limited relationship or a weak relationship. Weak relationships, I still call them weak relationships, even though the official name is limited relationships, are relationships that have some limitations. Specifically, the most relevant one is that table expansion does not work across weak relationships. But apart from that, they work as regular relationships, meaning that if I now slice, not by age group, but I use the age group in the ages table, you see that I still see the same value as before. I have the age group, I have the sales amount, and I'm slicing one by the other. Now, as we did earlier, it's interesting to see the code that has been executed in order to understand it a bit better. So we can go to the external tool, launch DAX Studio, and we keep it here. No, we keep DAX. I want DAX Studio there. No way. DAX Studio. DAX Studio. Here, I want DAX Studio here. Okay. And then we grab the query that has been executed here. So we launch again the performance analyzer, start recording, refresh the visual, look at the code. We copy the query, and then we paste it here. Again, this is useful. I skipped it before, but it's worth discussing it a bit more now. When you paste code from the performance analyzer inside DAX Studio, the code that has been copied from Power BI Desktop contains both the DAX query and the direct query queries. When you are just learning, using both is useful. The first is the query that has been executed by the internal DAX engine, and there is nothing fancy here. What is interesting is the second query, and this is the query that has been executed by the remote server. It's quite complex and it's not worth looking at all the details, but can you see the amount of numbers that is passed back and forth between the two engines? It creates a variable that contains the three categories and then a second variable that basically contains the age and the category. So 20 is age 3, 21 is age group 3, 22 is age group 3. So that this variable can be used by the remote engine in order to compute the result. Indeed, what is happening is that because the ages table is a local table, it's not a remote table, it's a local table in the local Vertipack engine. Whenever a query involves both a local table and the remote table that are joined with a relationship, the engine needs to send the entire content of the local table to the remote server in order to obtain the result. Performance-wise, it is still very good. You can slice by gender on the columns, and you see that it is very fast. The reason is that the age group table only contains 100 value. Actually, only 67 values. So it's a tiny table, and this is not a big issue. But, and this is important, you need to pay attention to the fact that if you create relationships between remote tables and local tables, then whenever a query touches both tables, either the content of the remote table needs to be retrieved by the local engine to perform the join locally, or the content of the local table needs to be pushed to the remote server so that the remote server is able to perform the join and produce the final result. In those scenarios, this is a very expensive operation. With a table with 100 rows, performance are still extremely good. But if you plan, for example, to create a local table that contains something like sales, so a table of the same size of sales, you don't see it here, but that table contains around 10,000 rows, and then you create queries that use both tables, performance will go south very, very quickly. The reason is the entire content of either the remote or the local table need to be pushed between the two engines, and this is extremely expensive. And this is useful to start making the first consideration. As you have seen, we have the option of creating calculated columns. We did it for the age group that now no longer works, but it worked before. You can create calculated columns, and you can actually do great things with calculated columns. You can solve entirely the ABC analysis. You can build different calculations in a very simple and smooth way. So if you have a remote model and you just want to add some calculated columns, you only need to pay attention to the fact that that calculated column will be computed every time. But apart from that, you have no issues. You can create local tables in the local model and then build relationships between the local table and the remote table. As soon as you do that, as we did here, you need to start to understand better how the query is going to be executed, because if a table is a small one like ages, that is totally fine. It works. But if you create a table of the size of customer or the size of sales, then performance will be horrible. I remember Jeffrey Wong described composite model as a feature that you can use to extend your model, but you cannot use to design your model. And this is important. If you have an existing model that already works and you just want to extend it with some code or a couple of small tables, that is fine. This is what composite models are designed for. But if you try to think about composite model as a design, as an architectural structure, so something that you can use in the design of the entire architecture by building different layers of composite models in order to obtain the final model that is going to be used by your customers, this is a terrible design. It will never work because you are creating joins between tables that are quite large, and you are putting in charge of the server the task of pushing these tables back and forth all the time. So the first important limitation is the fact that the tables that you use to do the extension need to be either small tables or tables that are never used in combination with the existing tables. Because if I run a query that only uses the ages table, that query will never be pushed to the remote server because the local server is totally able to scan this table and produce the result. But as soon as you have what we call retail queries, just the opposite of wholesale, then you need to pay attention to the fact that retail queries can be extremely heavy. Moreover, there are some other limitations that you need to obey. For example, as I said, most of the metadata of the remote model is copied in the local model. Some information are only linked, some other are entirely copied. For example, I might say that I don't want the age column to be named age, and I might want to rename the age column. So I go here and I call this customer age. That works. I now have a copy of age, not a copy, but I renamed the column that originally was named age, and I renamed it as customer age. That works. Renaming a column is an option. I might say that I don't want this column. And the thing is, you cannot delete it. There are no ways you can delete an object that exists in the remote model. I might want to do the same with the table. Delete it. Not customer. Let's go for store. Let's say that I want to delete store. Click on OK. Now store disappear. I know this looks quite weird, but you can actually remove a table that is no longer here. You see that store is no longer in my model. But you cannot remove individual columns of one table. I don't know if the reason is security or the reason is that you cannot run queries that use a subset of the tables, but you can extract part of a model at the table level. You cannot decide column by column what to do. Let's go for the measure, for example. I can go to sales amount and rename it. That works. Sales amount can be called my sales amount, and that works just fine. Now the measure is named my sales amount. But as you see from here, I cannot change the code of sales amount. Again, this is mostly for security purposes. If there is a measure that has been created in the remote model, the control over the code of the measure is in the hand of the developer who created the remote model, not the one of the local model. So you can rename a measure, you cannot delete a measure. What you can do that is quite weird and to me is absolutely wrong, but just keep in mind people can do that. Now that I rename my sales amount, nothing prevents me from creating a new measure that I call sales amount, and my sales amount compute my sales amount times 1.5. By doing that, and then by hiding my sales amount, which I can do, I can hide a measure. Now my users will have a report where they could put sales amount, a measure named sales amount that produces numbers that are very different from the original ones. So again, having the option of renaming a feature poses some security issues that you need to be aware of. You might be in a scenario where a user starts to change names of measure, hiding measures up to the point that it is really hard to understand exactly what numbers you are seeing, and it is extremely hard to compare the remote model with the local model. But you have the option of doing that. Besides, the last detail that I think is important to note is how measures and entities are copied or linked. As I said, sales amount is my new measure, but let's look at margin. Margin is a measure defined in the remote model, and it is not in the local model. The same for margin percentage and sales category. The code of this measure is not copied in the local model, and this is important for intellectual property. If you build a measure, you know that even though you publish it on the cloud, the code of that measure, that is your intellectual property, is still yours, and a composite model doesn't have access to the code. What the composite model does is it generates local measures that reference the remote measures. And we can see that if we launch from external tools Tabular Editor, because with Tabular Editor we have a better technical view about the details of how this data is stored in model.beam. We can look at the sales table. Let's look at margin. Look at the code of margin. The code of margin says margin is not a measure in the local engine. It's an external measure in the Direct Query Analysis Services Contoso 10K, which is a special connection that has been created to link the composite model with the remote model. Its result is a currency, and the original name is a margin. The original measure to which this is linked is margin. That is the reason why the code of the margin measure has not been copied here. What happens if somebody changes the remote model? Well, if the remote model is changed, then the engine will search for the new version of margin, and it will start using the new version of margin stride. If you rename the column and you change the original column, the engine keeps track of the data lineage of, not the data, but the lineage of the metadata, and changes the details about entities that have been copied in the local model if you did not change them. So for example, if a user renames in the remote model the margin measure, that measure will have a new name also here. But if the user, that was a bit too much. I just wanted to unhide my sales amount. No way. So let me go here. Don't hide. Okay, and then get rid of your hidden. My sales amount, I renamed my sales amount, meaning that if anybody changes the remote model renaming or changing the code of my sales amount, the rename of sales amount will not affect this measure because I changed the property. Any property that is changed in the local model overrides the original property of the remote model. Any property that has been originally copied from the remote model but not changed will be overridden by any change that happens in the remote model. There are some other limitations, but we do not have time to go through all of them. There are limitations in terms of relationships. I cannot delete or disable remote relationships. If you try to double click on a relationship here to change anything, now you're not seeing it, but I'm desperately trying to double click on this relationship or right click, and I cannot do anything. I cannot change the relationship between tables. So I cannot make a relationship bidirectional. The structure of the original model needs to be the same. I can do that by using DAX code, but I cannot do that in the model. And then there are further limitations. So for example, I cannot create multiple relationships between local tables. If I want, for example, to create a relationship between customer key and customer age, it refuses to do that. It says table ages is able to filter remote Power BI data source or analysis services by reaching more than one table within the island. That is not supported. So if you have a local table, you can build a relationship with one remote table. You cannot a relationship with two remote tables. That's a limitation. That's a technical limitation that the engine is not able to produce the code that is needed to answer the queries. It might be lifted at some point in the future, but as of today, this is still quite a strong limitation. Now, I don't want to go further than that because I think that I stole already all of my time, plus the time that was required for Q&A. What I wanted to show you is, first of all, what are composite models? Composite models are models where you do not just link to a remote model, you extend the remote model. They are powerful, they are useful, they give you the capability of extending existing models, but keep in mind they are useful to extend the model. They are not designed as an architectural tool. You should not use composite model to design complex architectures of multiple layers of composite models, because this is going to kill performance of your engine. And at that point, you will start blaming Microsoft and composite models that do not work. That is just because you are using them the wrong way. If, on the other hand, you use them in order to add some local tables to your existing model, build a couple of relationships, build simple calculated columns, then they are awesome. I think they are really a game changer because they give you the option of building a corporate model on the web and then extend it with multiple local models, each one for the specific needs of the users who are using them. I'm not going to talk anymore. I already promised that earlier and I didn't do. So I think, I don't know if we have any question, but if we do, then we can start answering them.
Yes, we do. There is one not directly related to the session, but a question from Arfan. Is the DA100 a good qualification to pursue?
Oh, that's a very interesting question for which, unfortunately, I have absolutely no answer. Because I know the only thing that I know about the 100 is that everybody is taking this certification. Generally speaking, certifications are good because they force you to study also topics that people typically skip because they do not look interesting. But specifically for DA100, I honestly don't know because didn't participate in the creation of the training, and I didn't take it. I'm pretty sure that I would not be able to pass it because it's likely to ask questions that are not specific to DAX. But I'm sorry, I cannot answer. Generally speaking, I think that certifications are good because they force you to study the right way.
Okay, next one from Brandon. Does Power BI allow you to mark those, so the colors in a visual way between local or remote?
No, unfortunately not. The only place where you have a difference between local and remote entities is in the diagram view. There you have in blue and in white. In blue you have the remote models, and in white you have the local models. Actually, you can have multiple. I haven't shown you that, but you can guess that you can have multiple remote models. So it's not that they are just blue. They can be blue, purple, orange, different colors, and the complexity of the architecture grows exponentially. So extending one model is good. Extending 2 models or 3 models start to be a nightmare, and performance will be awful very, very quickly, much quicker than you guess. But then in the UI, in the user interface of Power BI, there are no difference. Users are not expected to know in advance whether something is local or remote. That's the real design of composite model, is to avoid users to have to worry about that.
Okay, next one. It's a longer one. I think you should read it directly.
Yeah, I can read it.
From Anthony.
I can read that loud. I was thinking of creating the main data model and import mode with all facts and dimension, except one large fact table that causes the PBIX to exceed the 1 GB limit for sheer capacity. As many visuals use this large fact table, I was considering adding this fact table to a data model on its own and publish it. Then connect the main data model to this dataset over direct query for Power BI. Would this be a realistic option? I would say not at all. Meaning that you are not extending a model. You are actually using, that's exactly what I was saying at the beginning. You are using composite model as an architectural tool. So you have a large model that for whatever reason needs to be split into smaller chunks. And then you use composite model to merge them from an architectural point of view. Keep in mind, a table with 1,000 rows is already a large one for composite model, because 1,000 rows means a DAX query of 1,000 rows that need to be passed back and forth between the engines. But 1,000 can still be good. What if it's 1,000,000? Imagine that you have a table in the local engine and a table in the remote engine, and both contain 1,000,000 rows. Any query that uses both tables at the same time will have to pass 1,000,000 rows in the DAX query between the 2 engines. That is never going to work. You will wait for minutes every time you want to refresh a single page, because you're using composite model for the wrong reason. That is, you're using to build an architecture instead of just extending the model with small tables. That is the real purpose of composite models.
Okay, one more from Rajesh. How direct query with data flow works? Well,
direct query that is not related to composite models, so we're not talking about direct query for analysis services. Direct query with data flows. Again, I don't have specific experience with data flows, but I have quite a good experience with direct query, and I'm not a big fan of direct query at all. Meaning that if you are seeking for performance, the only engine that actually gives you performance is import mode. Anything else is going to be incredibly slow, because the speed depends on the server to which you are connecting. If that is a very fast SQL Server, you might have good performance, even though you still have model limitation. Specifically with data flow, I honestly don't know about the details of the performance, but I always ask people, why are you using direct query? So you shouldn't think about direct query as the default engine of Power BI, because that is not the default engine. The default engine of Power BI, the engine that makes Power BI so simple, is Vertipack. So import mode is your default choice. Whenever you think about using direct query, you should have a good reason for that. So the real question is not what I think about direct query over composite over data flow, but why are you using direct query against data flow? You use direct query either because the model is extremely large and then data flow is not likely to be your best option, or you use direct query because you want real time. And again, data flow is probably not your best option. I don't want to say that direct query doesn't, no, that would be too strong. It's not that direct query doesn't work. Direct query is a very technical tool that you use in specific scenarios. And if you do not hit one of those scenarios, just stay away from direct query. Life is so much simpler with Vertipack.
Okay, let's see the next one. Actually, Bernat had two questions.
Oh, they are coming in the meantime because I see the
Yeah,
list
yeah.
is growing. Well, there are two from Bernat. Do you have an idea when will direct query reach general availability? I have absolutely no idea. And I guess you know, even if I might have any idea, I wouldn't be able to answer you. So any answer is just, I don't know. Is direct query a measure of last resort? That's interesting. I think I already answered to you. To me, yes. So you use direct query when either the data model is so incredibly large that it doesn't fit in memory. And keep in mind, so incredibly large does not mean a billion rows, because a billion rows, you can just use import mode and live happily. There are no reasons to go for direct query for that reason. You need to have tens of billions, hundreds of billions of rows. There you start thinking about direct query. But any SQL server with 100 billion rows will not be really comfortable. Therefore, you need to really pay attention to how to optimize the details. Or when you need real time. Real time, direct query, that looks like the perfect scenario. And again, I'm not a very big fan of real time at all. I think real time is abused these days. Everybody wants real time. To me, business intelligence is about analyzing the trend of the last 10 years. And if what is happening this morning is changing the trend of the last 10 years, then it's likely you are analyzing the wrong numbers. There are no reason to analyze at the same time, real-time and large historical data sets. Build two models, one for real-time, one for the historical data. And yeah. Again, life is so much easier.
One from Andrea. Did you ever have a situation?
Yeah, well, the amount of data was so large that the measure either took forever to calculate or just crashed. Well, I would say that this is my everyday experience, but that is basically because I'm studying most of the time. So I have a machine at home that has 256 gigabytes of RAM, and I send it out of memory quite often because my goal is to do that. Mostly when that happens is because either the data model is wrong or the DAX code is really awful. And there are not many other reasons. By the data model is wrong, I mean, mostly when you have large amounts of data so that it takes forever to compute, that means that you didn't reduce the data set properly. Again, if you have hundreds of billions of rows in your data model, you can easily reduce the amount of data. If you have hundreds of billions of rows and you have daily information and individual transactions, the sad reality is that nobody cares about individual transactions if you have hundreds of billions of rows. That means you can pre-aggregate values at the day level, at the product level, at the customer level, reduce the granularity of your fact table so that you no longer have hundreds of billions of rows. You go in the millions of rows range, or maybe 1 billion. And at that point, your data model will be able to answer quickly. Data preparation is something that people do not do anymore or do not do that properly because it looks cool to say that, hey, I have 100 billion of rows. But the sad reality is that you have too many rows. Your is not a cool model, it's a wrong model. You are trying to compute everything on top of such detailed data that by no means you will find a server that is able to answer in a good amount of time. So if you prepare your data in advance the right way, then you will quite never face data that is actually too large. So that is actually the answer to your question. I face that every day because I want to do that on purpose. But in real customer, whenever the amount of data is so large, I would say that more than 99% of the time, this is because they are using the wrong data model.
So it's a data modeling issue. If it's too big, it's a problem of data modeling, right?
Yeah, I would say so, yeah. There are models that are really huge, but they're definitely not common.
Okay, and two more questions. One from Daniel Perez. Are permissions required in the source model to view or use the composite model?
Yes, you have the option of prohibiting a model to be used as part of a composite model. And in that case, users will not be able to connect as a composite model to your original model. That prevents people from doing the game where we did the renaming measures and do stuff. Unless you trust your users to be able to use composite models, you can avoid using them at all.
And the last one from Christy Pristi. While direct query is not really recommended, should we still consider separating the dataset from the visual report into two separate objects?
That makes a lot of sense. So if the report is just a live connection to an analysis services model or a Power BI dataset, that is absolutely fine, because you do not have all the performance issues that you might have with a composite model. You just have a server and a report. So having two different objects makes a lot of sense. You might have different sets of reports, different people working on the report or working on the data model. So that makes a lot of sense. So it's only direct query and composite model. Direct query because I don't like direct query, because I see people abusing direct query all the time. And composite models, you need to spend time studying it really well before you start using them in production, and then use them as an extension tool. Do not use them to design your entire architecture.
Well, thank you. That was the last question, Alberto. Thanks again for joining and sharing your knowledge with us. We still have 5 more minutes from the meetup to run the raffle. So not sure how familiar are you with Enterprise DNA and their learning resources. I know them,
of course, they are.
But they are our primary official sponsors, and as I said at the beginning, they are offering 3 annual membership. It seems that we had in the raffle 12 people participating. Let me refresh the data. So the raffle is running like this. We are filling up the form. I'm using Power Automate, a flow, to fill up a SharePoint list. And then the Power BI report, it's linked to that SharePoint list. And I have a Power Apps inside Power BI with a random generating number. So depending on the ID of the participants, we'll get the winners soon. So let's start with the first winner. I hope this time it works, because I had some problems. On the first meetup, I actually had some problems. So Anthony is the first winner. Congrats, Anthony. Let's refresh the data. This should be 12 here, going to 11. 1 winner. Okay, let's go with the second winner. Luis Serra, the second winner. Congrats, Luis. And refresh. And the third one, Daniel Perez. Really cool. Congrats, Daniel. I'll contact you on email afterwards, just to follow up on the membership. You'll probably get the membership in the next few days. It's just a matter of confirming the email addresses and make sure the enterprise DNA is following up and set you up the account. Thank you again, Alberto, for coming
Thanks
and
again to you.
presenting to us. Thank you, everybody, for joining this session, and see you next time on the November meetup with everybody else. And I'm pretty sure everybody is following you on YouTube and on Twitter, and stay up to date with your content. Thanks again for everything you're doing for the community, Alberto.
Thanks to you, and have a good night then, or wherever, depending on the world where you are, have good whatever.
Yeah, it
Thank
seems the spread was pretty from US to India. We had people from everywhere. So
cool.
Thanks again, and see you next time.
See you next time.
Ciao, and enjoy DAX.
Enjoy.
Thank you, Alberto.